Welcome to the VirtualZ FlowZ demo. FlowZ is an exciting new mainframe software product that we've developed, and what it does in a nutshell is it makes it very simple, very straightforward to get mainframe data to just about anywhere, whether cloud applications, network attached storage devices, just about anywhere. So we don't usually talk about the installation process, but I just wanted to spend a minute on that and show how simple it is. What you see is just a normal shell session on my mainframe. I have the FlowZ distribution, as you can see, and all it takes is a single pax command, to explode that archive. It runs, and you'll see a directory structure, such as on the video. This is the FlowZ product is pretty much ready to go like this, and as you saw, it can be installed literally in seconds. So when we talk about you can be productive, the same day you receive the package, we're not exaggerating. It's one of the easiest bits of mainframe software you'll ever deal with. Now, in the demo today, what we're going to look at is we're going to be sharing some mainframe data with a SAN environment, and in this case, I have a physical SAN device that's set up to be network accessible to my ZOS system. What we're looking at here is basically the control panel or the desktop that comes with the software. In this case, it's running right in my browser. And what I've done up to this point is I've just configured it to have an NFS link to my mainframe. So what I'm going to do now is I'm going to go into the various shared directories and I'm going to create a new one. I'm going to create a folder that I'm just going to call FlowZ. And of course, it could be named anything. You could do this a lot of different ways. This is just one example. And of course, we can support lots of things beyond SAN environments. And you'll see we're starting with a nice, empty, clean directory. Now, back on my shell session, I'm going to do a little bit of setup work on ZOS. Probably the most important thing is I'm going to connect my mainframe to that folder that I just created. And this is done with a normal mount command. I can specify whatever file system name I want. That's just a logical name that ZOS is going to know this file system by. And, as I mentioned, it's NFS. So I'm going to specify that. I'm going to specify that I want read-write access. I'm going to specify where it appears in the ZOS file system /mount/NFS. And that parm is everything needed to connect. So my IP address and the name of the folder we just created, volume1 /shared/FlowZ. A lot of ways this could be done. This is just one example. You can automate this with FlowZ so that it happens under the covers every time a file is accessed. Totally up to you. Just showing this is kind of a simple way to understand what's going on here. So I've got my mount command, and I'm going to enter that command, and fraction of a second later it works. It's authenticated me. It's done all the things that our NAS device wants. And if there are any questions, I can use the display file systems command. And I see /mount/NFS has a file system called FlowZ mounted on it and some other statistics. So with the mount point created, now I can use FlowZ to create what I think of as a pipe, a local file system object on ZOS that's going to connect ZOS to that to that SAN resource that we just created. So I enter the command. You can see the output here. Nothing complicated. What I've done is specified the local name, the pipe file. That's the name that I'm going to reference the storage through. And I specified a target. In this case, it's a static target, but it doesn't have to be a static target. It could be a dynamic thing. Think almost like a GDG, that the name changes every time it's accessed. It might have the username, a date, whatever you need to be connected to it. and I see where it is, and I see that the creation of the object worked. If you ever have any doubt, we maintain the status of all of this. So, we see, FlowZ status will show us what we've created. If we've actually accessed data there yet, we would see byte counts and all of that. So I'm going to do a really simple thing. I'm back in a TSO session here, and I'm going to use some JCL to copy a little bit of mainframe data to that link I created. So I'm running, nothing even proprietary from us. I'm running the standard IBGen or IBM utility. My input is what you see, hello from ZOS, and the output is that object that I just created. So I submit this JCL. It runs nearly instantly. And now I've got data back on my SAN environment. Now let's go look at that. Back on the SAN desktop, I'm going to head back into the File Explorer here and see what we have. So again, this would look a little different depending on the kind of file you create. In this case, I open up, I'm still in that FlowZ shared file, and I see what we did. I see an 80-byte file called my file, and that's exactly the data that we sent to it with that JCL. You can see the properties, you can see the timestamps, security information, all of that is visible at this level. So, if I had another application, let's say running in the cloud that needed to reference this, that data is there for him, bit for bit. It's the same as what we put into the system with JCL in this case. Certainly, I could do it in a lot of ways. I could do it with command line functions. I could do all sorts of things. So, we've created I think of it as a trivial amount of data. Let's look at something maybe a little more complicated than that. What we're going to do now is we're going to create, same process. We're just going to create a different file. We're going to create something, and then we're going to take a system backup to this target. So I'm creating a pipe here called my_NFS dump, and I'm mapping it to my dump on my SAN device. You can see the results, same thing that we looked at before, just different names. And now I've got that object. So I'm going to go back again to TSO, and in JCL, I'm going to run IBM's DFDSS dump restore utility. Now, to make this work best with FlowZ, there are a couple of small JCL changes we make. First of all, instead of running the normal program name, we change that to FlowZ DSSU. It's basically just a small API example using DFDSS where we can load DFDSS and execute it through FlowZ, which allows us to capture the output and redirect where we want it. In this case, you'll notice I have a step lib. I mean, that's totally up to you. I mean, you as part of the install, you'll see how in the README file you would create this program. It's just running a link edit job. But the key is that I create a special DD statement, FlowZ dump, FLZ dump. And I point that, again, just like we saw with IBGen, I point that to the dump that I want to create in the network attached storage device in this case. Beyond that, it's just standard stock DFDSS. If I wanted to, I could write the dump in parallel both to a local file, maybe I want to, I don't know, a virtual tape or whatever else, as well as in SAN device. I absolutely could do that. In this case, I'm just using DD dummy because, frankly, we don't have the disk space to hold duplicate copies of the dump. But the control statements, we're taking a disk volume called B3 Res 1 that happens to be a 3390. We're going to take a full volume dump of it, and we're going to use the hardware compression feature on the system that I'm on. And again, all of the DSS control statements, everything about it is exactly the same. It's just that we ask you to change the program name so we can intercept some of the I/O that would normally go to tape or whatever it is. So I submitted that JCL. We can kind of watch it run. I mean, this is a 3390 disk volume, so it's in the order of a couple of gigabytes. We can see it running here. It's chugging along. It's doing its thing. We can see thousands of IOs per second being issued here. And we actually can look at the output, and just to confirm what I said before, you'll see the bottom half of the screen shows just standard DFDSS, and that's it. It's done at this point. In our testing, we find that a 3390 disk volume can be dumped to our SAN device in about a minute and 20 seconds. If I look at the output here, I see exactly that. I see a minute and what is that? A minute and 24 seconds. So, and again, keep in mind our development environment is a very small, very, very limited system. If I toggle back to the SAN desktop, I see the dump that we just created. I see that it's 1.63 gigabytes written in the time that we were looking. And again, I want to be clear, we're running on a ZPDT system. It's basically ZOS running on an Intel hardware processor, a desktop PC. The SAN environment we have is a little baby thing that we do testing with. It's not like industrial grade anything here. So we did dump that 1.63 gigabytes in about a minute. And it is exactly what we expect it to be. I could do as many of these, as few of these as I want to. So that's the quick version of the demo. You've seen what we support in terms of targets. You've seen how to use it, how the installation works, and maybe even gotten a sense of the performance potential here. We look forward to hearing from any of you. If you have any questions at all, want to see different demos, have a technical conversation with us, by all means, don't hesitate to reach out. Thank you.